Welcome, Honors Algebra 2. This is Mr. Landa. We are going to get rolling. This is the very first ever flipped video by me, so we'll see how it goes. Probably pretty rough, but let's get rolling. So this is the assignment sheet you get passed out to you. We are going to cover 1.1 and 1.2 today. Get two sections tonight. The properties of real numbers and simplifying is kind of the main subject or topic. Here are the learning targets, which you should be using these to help review for quizzes and tests. We're going to classify numbers. We're going to be using some basic properties. These are 4 of them we'll look at. And we'll look at how to simplify expressions with keeping order of operations in mind. So here are some number systems we got to talk about. A number line is what it says it is. It's a line with numbers. And so you make this, it should have arrows so it's continuous. It has intervals which are consistent, and you can choose what numbers you want. So if you just want to go by 2, so 2, 4, 6, 8, 10, 12, and it keeps going. So we'll have 0 on here, you don't have to. Number sets, whole numbers, a lot of you know these. 0, 1, 2, these do not have decimals. They are also not negative. Integers are similar to whole numbers. They actually include the whole numbers, but they also include negatives. Those are integers. You should know these by name. Rational numbers. These ration, fraction. That's kind of how it helps me remember. So a fraction like 1/2. They also could be fractions that repeat. So 1/3, which is 0.3 repeating. So they are repeating decimals or terminating decimals. So 1/8. Those of you that use a tape measure a lot should know that 1/8 is 0.125. Irrational numbers are numbers that are not rational, obviously, which means that they do not stop, terminate, or repeat. Non-repeating decimals, non-terminating decimals. So the first number everyone gives me is pi, because they know it's a non-terminating value. The other numbers, there's one right here actually, square root of 2, or square root of 3. Not square root of 4, but square root of 5. So these are the square roots of non-perfect squares. So those are irrational numbers. We can take these number sets and we can actually make a Venn diagram. Let's put a big circle here. We'll make this be the irrational numbers. So these are all irrational numbers are inside here. And then we have all rational numbers would be in this set. Those do not overlap. But inside rational numbers we can have all of the integers. And then inside integers, we have all of the whole numbers. So kind of some Venn diagrams to show you how the numbers relate to each other. So there are some integers that are not whole numbers. There are some rational numbers that are not integers. Whole numbers are integers, but integers are not whole numbers. So can you see how that plays? So we can actually plot these 3 numbers on a number line. So we basically just draw a number line. We'll put some intervals on there. We don't even have that many. We only plot 3 numbers. Realize I'm going from -1.25 to 1.5, about there. So if I put 0 here, let's put a more mark here. So we'll go by halves. So this is going to be -1. And this will be 1. I should probably have another tick mark here. Then -5/4 we use filled in circles. So it's -1/4. Let's do 0.9. 0.9 is right before 0.1, obviously. And then square root of 2. I know square root of 1 is 1. I know square root of 4 is 2. Square root of 2, I know that value. I know approximately what it is because I know 2 is closer to 1. It's closer to 1 than 4. So square root of 2 is going to be closer to 1 than it is to 2. I also know it's actually about 1.4. So I can put a big fill-in circle there. A little messy, but let's keep moving on. So some more properties we know. We have A, B, and C are real numbers. We have these 2 properties which kind of do the same thing, kind of mean the same to me. The difference is commutative uses two numbers, so I think of two m's, two numbers. So we have a times b equals b times a. The order does not matter. It also works with addition. So you can flip the order, it still works. Associative is the same property, except it's got three numbers. So those three letters helps you memorize three numbers, three letters, three variables. So ABC is flip the order around. Let's do BAC. It also works with addition. The identity. So identity is we're not going to change the value or identity of the variable. So I don't want to change it. So what can I multiply to it that doesn't change it? 1. So we call 1 the multiplicative identity. We can do the same thing for addition. I do not want to change a. When I add to it, 0. So 0 is called the additive identity. So what you can multiply or add, it does not change the identity of the value. The inverse, there's the inverse you guys know as two different things. For multiplication, you know it as the reciprocal. It's probably where you've heard that in the past. And for addition, you know it as the opposite. So that makes it a little clear for students. A plus negative a is 0. That's just the additive inverse. And for the multiplicative inverse, I do a over b times b over a. It's going to equal 1. And the reason why that occurs is because if you actually divide b divided by b, you get 1, and a divided by a, you get 1. We'll skip the distributive properties, keep moving on. Let's do this example here. We're going to use the multiplicative inverse of units to convert 1 mile in 5 minutes to miles per hour. So you can't quite see the end of this. So we can fix that. There we go. So to convert that, let's first write the fraction. 1 mile per 5 minutes. That's what's given to us, that rate. So if I'm on the treadmill running, I'm going to finish a mile in 5 minutes, how fast am I really running? So to do that, we can use the multiplicative inverse. To do that, we want to put minutes on the bottom, we want to put minutes on the top. That's the inverse, because I want to get rid of minutes. Do I want to get rid of miles? No, because it tells me I want to have miles as my answer. But I want to have hours, so I need to get rid of it. Now I can't just multiply by anything I want. I have to multiply by a value of 1. So this fraction here has to have a value of 1. So I can go from minutes to hours though pretty easy if I know of the equivalency that 60 minutes is in 1 hour. That's the same thing. So this fraction is actually equal to 1. So I'm not changing the value, I'm changing the units. Minutes. In minutes, those reduce out because I have minutes on top, minutes on bottom, which is 1. So now if I multiply straight across, I get 60 over 5, which in mental math, I know that that is 12 miles per hour. So when I run my mile in 5 minutes, I'm actually running 12 miles per hour. So powers, exponents. So we want to evaluate this. 2 to the 5th is how that's said. 2 is the base. 5 is known as the exponent. Blank is not big enough. And then what is the power? The power is actually the entire thing. 2 to the 5th is the power. Just a quick refresher, 2 to the 5th just means we have 5 2's, which should be the easy one. Here's multiplying by 2's, here's doubling. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 will be 32. Should not need a calculator for that. A variable is just a symbol. A symbol that represents. Use my writing, I'm getting used to my tablet, which is very small. Symbol that represents a number. So wherever you see a symbol, so example of that, like X, it really means a number. We just don't know what it is. It could though be a star, it could be a heart, it could be whatever you wanted to, just examples of variables. Moving faster, we have grouping symbols, which are parentheses or brackets. Those are attached to order operations. For the order of operations, we know that as PEMDAS. But when we say PEMDAS, it tells me the order to do it in. But a lot of students think multiplication and division are 2 steps. Really, those are 1 step. Multiplication, division is 1 step. Addition, subtraction is a step. So we have parentheses, P, which is really any kind of grouping symbol. Then we have exponents. The second, we have to do it in this order. If you don't, you will not get the correct value. This is multiplication, division, left to right. So whatever comes first in the problem, left to right. And then addition, subtraction, which is also left to right. So this problem right here, I'm going to give you a second to complete that. What do you think that value of that would be? 6 divided by 3 times 2. Let's go ahead and evaluate that. You should be able to do that mentally. And if you do it mentally, hopefully you get one of these 4 answers, and hopefully you get the right answer. 2 of these that students usually give me is A or C, 1 or 4, so I'll narrow it down for you a little bit. But if you use the order of operations, we have to do what comes first in the problem. Multiplication, division, what comes first, so we actually have to divide first. So 6 divided by 3 is 2. Then we could do that answer 2 times the rest of the problem 2 to get 4. So the answer is 4. Just looking at the order of this problem, we have to do the exponent first, then we can do the multiplication, then you can do the addition. So you have to follow order operations.